revolution, we talked about revolution, when one object's going around another object. Since we did evidence of rotation, we must also talk about evidence of revolution. Two different ones we need to look at. One is seasons. Because the Earth is tilted at around 23 degrees, and it's not perfectly straight up and down, we get seasons because with the tilt of the Earth, there's times that the sun is shining more on the southern part of the Earth, and sometimes it's shining more on the northern part of the Earth. With that one, we get different amount of daylight. The different amount of daylight is going to tie into heating up the Earth's surface. So if I'm looking at my seasons, summer, also known as your summer solstice, June 21st. For us here in the northern hemisphere, it's the day that we have the most daylight. If I'm looking at the southern hemisphere, it's the day they have the least amount of daylight. The sun is the zenith. Remember, zenith is whatever is directly above. Sun is the zenith at 23.5 degrees north latitude, also known as the Tropic of Cancer. You guys have this Tropic of Cancer labeled on your Earth Science reference table on your map. If I'm looking at the Arctic Circle to the North Pole, this is the day that you have 24 hours of daylight. They never get darkness. South Pole, totally dark on June 21st. Now the opposite is true for the winter, also known as the winter solstice. December 21st. It's the day that the northern hemisphere has the least amount of daylight because the northern hemisphere is tilted away from the sun. The southern hemisphere gets the most amount of daylight because the southern hemisphere is tilted towards the sun. Arctic Circle to the North Pole, no daylight. South Pole, 24 hours of daylight. So the sun is the zenith. For the winter solstice, Tropic of Capricorn, also known as 23.5 degrees south latitude. All right, spring. Spring, better known as the vernal equinox. You're looking at March 20th or 21st. This year, we had a leap year and it was actually the 19th. Late in the evening, the sun is the zenith at the equator. It's an equinox, equator. All right, everyone on the Earth, doesn't matter your latitude, has approximately 12 hours of daylight and darkness. It's equal. All right, equinox, equator, equal. The fall or autumn, known as the autumnal equinox, same thing. All right, the sun is the zenith at the equator. Everyone, no matter what your latitude is, has approximately 12 hours of daylight and darkness. And the dates, you're looking at September 22nd or 23rd. Okay, I want to explain, for those that are going over the review book and you're on page 62, you're looking at figure 4.3 and going, what the heck does this mean? It's going to relate to your seasons. So, with this one, here's my celestial sphere, west, east, so that's my equator. Here's south, here's north. We have to plot our two equinoxes and our two solstices. So if you're looking at, for our perspective here in Syracuse, New York, winter time, which is December 21st, winter solstice, least amount of daylight. The arc is low in the sky. So the sun appears to always rise in the east, set in the west, because the Earth rotates counterclockwise or west to east. So if we're looking at ours, it's lower in the sky. So my sun is rising, coming up, hitting its solar noon, and arcing back. All right? So it's going to be lower in the sky. So we're going to say that's December 21st. Probably actually even a little lower. So with that one, we would say the sun rises east of south and sets west So you're always comparing. Here's south, here's east, and here's west. Sun is rising in the east, setting in the west. So afternoon, I'm over here. So this is my PM. This is my AM on this side. So the sun is rising south of east, and it is setting south of west. So right here, as long as I'm in this section, I am always rising south of east, and I am setting south of west. Now, if I'm coming into my equinoxes, be it the vernal equinox, which is March 20th, 21st, or if it's the autumnal equinox, September 22nd, 23rd, it's rising on the east, and it's setting on the west. So that's either March 20th, 21st, September 22nd, 23rd. Now, that's how it's going to appear for us. So it's rising east and setting in the west. If we're coming, remember, equinox, everyone on the earth has about 12 hours of daylight and darkness. If we're coming into our summer, so we're looking summer solstice, the northern hemisphere is tilted towards the sun, we have more daylight, so my sun is rising over here, north of east, and it is setting north of west. All right, and that would be our June 21st. Notice the arc is higher, it's longer, the sun is in the sky longer. So this is where the sun would be at solar noon. Solar noon, remember, is the time of the day when the sun is at its highest altitude. So once again, anywhere from, let's start with June 21st. If I go from June 21st, end of June, July, August, beginning of September, September 22nd, 23rd. All that time before I get to the equinox, my sun is rising north of east, and it is setting north of west over in this area. Get to my equinoxes, rising in the east, setting in the west. So here I am, March 23rd, and not March, September 23rd, and September, October, November, December 21st. All this time, then I'm coming back. December, end of December, January, February, March, until I get to the vernal equinox. That whole time, the sun is rising south of east, and it is setting south of west. So from this arc to there, and then from this arc to there. I get back to a vernal equinox. Here I am, end of March, April, May, June 21st, I'm back at my high point. All right, so at that time, I am rising north of east, and I am setting north of west. All right, so it's oscillating between those. That's your low, and that's going to be your high. Back and forth. Now, in your review book, if you start after your reference table, there's a section as an appendix. And the first part after that talks about your performance test, which you guys don't have to worry about this year. Next one talks about landscape regions. And if you flip over to A22, A23, 24, 25, it all shows you a variety of what these will look like if you were at different latitudes. So what I want to do is I want to look at these again, but I'm going to ask a couple questions. So I'm going to back these up. So that was all us here in Central New York. Now, if I had something that looked like this, where the sun is dead overhead, the equator, and I'm rising in the east, setting in the west, and I said, all right, what's the date and where am I? The whole idea, you would know the date. I'm an equinox. I'm rising on the east, setting on the west. All right, I would know my latitude because the sun is the zenith. So the only place the sun can be the zenith on an equinox is the equator. So you would have to try to figure out where you are based on that knowledge. Now, if we had the lines instead of how I had them all coming over on this side, if I had them going this direction, oops. If I had them going this direction, that would show me that they are in the southern hemisphere. All right? Latitude-wise. So make sure you're looking at your review book on the appendixes to try to figure out location. How do you know your location? And how do you know the angle? That one is going to probably be your hardest thing right there. All right, so use those as a reference. If I go back to the one I originally had for us in Central New York, the angle difference from here to here, we'll say it's 30 degrees, we'll say it's 23.5 degrees. That has to be the same angle from here to here. All right, so those angle changes have to be the same. The other piece of evidence that we know we revolve around the sun, besides seasons, is seasonal constellations. Now, if you remember walking through the alcove, one side had winter constellation like Orion, while the other side had summer constellations. So they're seasonal constellations. You don't see that constellation all year long, unlike a circumpolar constellation. Okay, welcome back to the alcove. Here's what you guys been walking through all year long. So if you're entering into, as you're going into the room on the right hand side, these are the lockers on the right hand side. And these are your constellations that are known as your winter constellations. So Gemini, Orion, Taurus. Orion is one of those that, you know, is easy for you to see. You probably can see that one. You've probably seen him. The 3 stars gives it away. And then on the opposite side, as you're walking in on your left-hand side, were your summer constellations, Pegasus and Cassiopeia. Pegasus is a horse, that one I can see. Cassiopeia is supposedly a queen sitting on her throne. That one personally I don't see. So those are seasonal constellations. Circumpolar constellations, ones that we see all year. Here's the Little Dipper, it's the one that's directly over the door. At the end of the handle is Polaris. Alright, you use the Big Dipper, which was in the entryway. To figure out where Polaris is. So these 2 stars are your pointer stars. So if I'm looking at it, here's your handle over here, here's the cup, these 2 stars together, if you connect them and travel a straight line, they point right to Polaris, which is at the end of the handle of the Little Dipper. Alright, let's talk time. Solar time is time by the sun. Solar noon, you already have this in your vocab, is when the sun is at its highest point in the sky. Solar noon is not happening for everyone at the same time. If you have the same longitude, you have the same solar noon time. Now, if you're looking really quick, Earth's rotation causes solar noon to move westward at the rate of 15 degrees each hour, or 4 minutes each degree of longitude. Those that are in the middle of their time zone, they actually have solar noon at noon. We are actually east of the center of our time zone, so our solar noon actually happens after noon on the clock. Okay, we're going to talk about standard time zones. Remember, there's 24 standard time zones here on the Earth. One for every 15 degrees of longitude, because remember, 15 times 24 is going to give me 360 degrees, my circumference around the Earth. We had talked about latitude and longitude earlier this year when we did topographic maps. So your standard time starts at the prime meridian. Remember, prime meridian cuts through Greenwich, England. It's 0 degrees longitude. As you move westward from the prime meridian, so from Greenwich, England towards us here in the United States, every time zone, we're back another hour. So if we look at our latitude being 75 degrees, 75 times divided by 15 is 5. We are 5 hours behind Greenwich, England. So right now, it's 10 o'clock in the morning here for us in New York State. That means that they're 5 hours ahead of us. They would be at 3 in the afternoon. If you were to go from the prime meridian and you head eastward towards Asia, they're actually, every time zone, they're actually ahead of the standard time. So with that one, if I went 75 degrees east longitude, they would be 5 hours ahead of the people at Greenwich, England. So if it was 3 o'clock in the afternoon Greenwich time, that add another 5 hours, and those people would be 8 p.m. International dateline, we talked about also when we did topographic maps. Remember, unlike the prime meridian, which is a straight line, international dateline is kind of crooked. It's so it doesn't, remember we said it doesn't cut a country into 2 different days, because the international dateline is separating today from tomorrow. All right, if we look at the United States as a whole, we're in the blue section, New York State. We are Eastern Standard Time. Orange, you're looking at Central, so like Ohio, Midwest there. The gold, Colorado is Mountain. They're 2 hours behind us. And then the green, we get into like California, Pacific time zone. They're 3 hours behind us. So those are the 3 that those are the 4 that you mostly hear about. You also have to remember that we also have Alaska and Hawaii. So they too have different time zones. We're going to focus on our 4, because usually when they had a regions question for you, didn't include Alaska or Hawaii, it was always on the primary 48 continental states. So for us, it's 10 o'clock. Here in New York State, that means in the Central Time, the Midwest, it would be 9 o'clock in the morning. For Colorado, being Mountain Time, it would be 8 o'clock in the morning. And for the West Coast, it would be 7 o'clock in the morning. So as you move westward with every time zone, remember, you're subtracting an hour. Looking at the calendar, it's all based on the Earth. So 1 day is the amount of time it takes the Earth to completely rotate or spin on its axis, which is approximately 24 hours. 1 month is how long it takes for the moon to revolve around the Earth. And that one you're looking at 29.5 days, as long as we take into account that the Earth is also revolving. 1 year is based on how long it takes the Earth to revolve around the Sun, which is approximately 365.26 days. Now, because of that 0.26 days, times that by 4, every 4 years we have a leap year, which we had this year. It's February 29th. Daylight savings time. Some people like it, some people don't. The person that's given credit for it is Ben Franklin. If you actually delve into history, you'll find out it wasn't really Ben. He got it from a different country. The whole idea is the purpose is to save energy. Not all states partake in daylight savings time. Daylight savings time for us in March is when we actually set the clock ahead an hour. So you got to school an hour earlier. It was darker for you in the morning. But when you went home, you had more daylight in the evening. Now, daylight savings time ends in November. So that means we set the clocks back an hour. So you get that extra hour of sleep. It's a little darker in the, at night, a little lighter in the morning. First established during World War I. All right, just a little review as we already talked. Prime meridian separates eastern and western hemisphere. It's a straight line, goes through Greenwich, England. International date line separates today from tomorrow. Not a straight line. It jags, so this way you do not separate or cut off a country so it's on today and tomorrow simultaneously.